Hello guys and welcome back to this amazing channel. This is Abhinav. In this particular video, we'll discuss about all the 4 problems of weekly Leetcode Weekly Contest 411. Yes, we'll discuss all the 4 problems A, B, C and D of this particular contest. First of all, sorry for recording this video late. Actually, I gave the contest and I slept. Okay, तो मतलब contest भी मैंने एक तो late start किया, 8:30 बजे around start किया, तो late उठा. मैंने 1 घंटे contest दिया, मेरे 3 क्वेश्चन हो पाए. फोर्थ वाला भी आज का उतना डिफिकल्ट नहीं था, बट बिकॉज टाइम नहीं था, आई वाज नॉट एबल टू डू इट. एंड देन मैं अगेन फिर सो गया. तो मैं अभी 12 बजे उठा हूँ. सो आई एम I have solved the question number 4 and then I'm recording this particular video, right? So yeah, we have 3 problems in this particular 4 problems in this particular contest, A, B, C and D, and we will discuss all that 3 problems in this particular video. I will say the contest was on a medium level. Even the first problem was very easy, a brute force. Second was a DP problem, okay, and then third problem was a very basic, I will say, mathematical problem, not sure what it is, okay. And yeah, fourth was a good problem. It can be either solved using segment tree. Segment tree is a, obviously is a very basic approach in this query problem, but it can also be solved in a greedy approach using binary search. So we'll discuss this binary search solution of this fourth problem, okay. Amazing. So let's discuss all the problems one by one. So the very first problem is that count subarrays that satisfy K-Constraint. So this problem was actually 2 versions. This is the first version and the second version was here, right? So I will discuss this at the last. Let's first discuss that version because both have a completely different implementation. So there is no need of, solving. So yeah, this first version was very basic. So they were asking that you have to tell the number of substrings which are K constants. ओके आपको नंबर ऑफ सबस्ट्रिंग बतानी होगी. के कॉन्स्टेंट्स हैं. अब व्हाट आर के कॉन्स्टेंट सबस्ट्रिंग्स? हु आर के कॉन्स्टेंट सबस्ट्रिंग्स? सो अकॉर्डिंग टू देम, a k constant substring is a substring where number of zeros and number of ones, either of them are at most k. मतलब या तो number of 0 k से कम हो या फिर number of 1 k से कम हो. तो either of both should be less than equal to k. If both will become more than k, so यहाँ पर people got confused. Either of them should be less, but if both will become greater than k na, then problem will be difficult. But if either of them, either 0 is less than equal to k or 1 is less than equal to k, then we will say it as a k constant subarray, right? So we have to find all the subarrays or the number of subarray basically which are k constants, right? If we will see here, the constants are very low here. The constant is just up to 50. बस 50 तक के constants हैं. So because it's just 50, we can even apply order of n cube time complexity here, and that is what I'm doing for the first question, right? So if you will see the first question of mine, what I'm doing is that I'm applying this first 2 loops of I and j. These both the loops are basically considering my subarray starting from I to j, and in every subarray from I to j, I'm checking that how many number of zeros are there and how many number of ones are there. How many number of zeros are there and how many number of ones are there. By the way, using prefix sum, you can also do it in order of n square time complexity, but that doesn't matter, right? Even n cube and n square both will work here, so I just use n cube, right? And then I'm finding the number of zeros, number of ones, and finally I'm saying that if number of zeros are less than equal to k or number of ones are less than equal to k, any one of that, either of two. If either of two are following this particular condition, that means it is a k constant subarray, and I will increase the answer, and thus I will count all the subarrays which are following this particular rule, right? So I hope that you got the understanding of this particular video. Again, it was a very basic solution, a very brute force solution, nothing to explain much. The time complexity for this, you can see it was order of n cube, but as I said, it can also be optimized order of n square if you will use prefix sum technique, right? Space complexity, as of we are not using anything, so it will be just constant space complexity that we're using here, right? Amazing. So guys, this is what the problem number first was, okay, and this is how we have just solving in a brute force approach. Amazing. Now moving forward to the next problem, which is this maximum energy boost from 2 drinks. This is actually a really good problem, okay, of dynamic programming. It is actually सुबह मैं बहुत नींद में था, तो मैंने इनिशियली इस प्रॉब्लम को ग्रीडी के थ्रू सॉल्व कर दिया. तो मैंने मतलब अप्रोच मैंने क्या समझी, आई थॉट कि आई हैव टू स्टार्ट फ्रॉम वन हाउस, देन आई हैव टू ओनली स्विच वंस टू द सेकंड हाउस. कि मैं एक हाउस से स्टार्ट करूंगा और सिर्फ एक ही बार दूसरे पे स्विच करूंगा. ओके, हाउस बोल रहा हूँ मैं, एनर्जी ड्रिंक से, ठीक है. एक से स्टार्ट करूंगा, दूसरे पे स्विच करूंगा एक बार सिर्फ. बट यहाँ पे क्या है कि यू कैन स्विच बिटवीन द हाउसेज मल्टीपल टाइम्स, एनी नंबर ऑफ टाइम यू वांट यू कैन स्विच बिटवीन द हाउसेज, you can switch between one house to the second house. That is what you can do here, right? But the thing is that when you are switching from one house to the second house, you cannot take the energy drink of that particular hour. Okay, let me give you example. Okay, let me give you example. And yeah, by doing this you want the maximum total energy that you can get in the next n hours. मैं बताता हूँ है क्या. तो आपके पास दो एनर्जी ड्रिंक्स हैं. फर्स्ट इज एनर्जी ड्रिंक वन, like this, and second is energy drink 2, and for both the values of their energy per hour is given to you कि भाई per hour दोनों एनर्जी में कितनी एनर्जी देंगे, that is given to you. For example, for this first energy drink A, energies are like this: 5 1 8 2 6 1 4, for example. And for B it is 2 1 9 6 2 5 8, right? इस तरीके से let's say that we are having the energies here, right? And so this is the 0th hour, first hour, second. I'm making zero based indexing. Okay, so here the value of n is 7. ठीक है, अब आप क्या कर सकते हो, that you can actually start from any of the energy drink. Let's say I'm starting from here. Okay, then you have two options. Either you will move forward to the next energy drink of that A, or either you will change the energy drink. But when you will change the energy drink, you have to skip one index. For example, I'm starting from 0. If I want, I can directly go here to 1, then do 8. But let's say after 8, I want to switch. So if you want to switch, you cannot go here. You cannot directly switch to the next index of the different energy drink. No. You have to skip one index and you have to go here. So these both will be skipped. Then listen now, when you got this and this. And you cannot just change this energy drink only once. You can change it multiple times. Let me explain you. For example, you started from this. Then you changed here. Then let's say you changed here, you continued. Let's say you changed here. And then here you continue. Right. This is how you will do. So you will either you can move forward in the same energy drink. Or if you are switching the energy drink from A to B or B to A, then one index in between you have to skip. You can see here. Ki what you can do. You have to minimize the total energy by drinking one energy drink per hour. तो एक बार में आप एक ही पी सकते हो, but you can switch between both the energy drink. But when you will switch, you need to wait for 1 hour. तो आपको 1 घंटे रुकना पड़ेगा. 1 hour मतलब you have to skip between one particular section when you are switching. Okay, and such that you want to maximize the number of energy, and then and also you can start from any of the two string. Okay. अब for example इस केस में आप देखो एनर्जी क्या होगी. In this case your energy will be, so from here it is 2 plus 8 plus 2 plus 5 plus 8, it will be 25 in this particular case, right? But maybe in some other case it will be maximized. Let's see, देखते हैं क्या कोई और केस है जहां पर ये एनर्जी मैक्सिमम हो सकती है. तो for example if we are, let's say, I think it's starting from 5, then I'm going to 9, then I'm going to 6, then I'm going to okay, yeah, 2, 5 and 8. यहाँ पे I think it will be max. I'm still not sure whether it is the maximum value, but it will be more than 25. So it will be 5 plus 9 plus 6 plus 2 plus 5 plus 8, and it is 5 5 10 19 25 and 35. ये 35 हो गया, right? And even maybe more than that is possible also. I'm not sure, right? So, but how we can do it? So see guys, this is not a greedy technique because we can change anywhere now. So we have to see that whether we should change the current energy drink or we should not change. So for that, we will apply dynamic programming. We will check for every possible combination and we will apply the take not take case here. तो कैसे कर रहे हैं? तो हम क्या कर रहे हैं? हम similar एक 2D array बना रहे हैं DP की of the same size. So basically these are two different arrays of size n. I'm taking a one array, a 2D array of DP of size n into 2. इस तरीके से. तो मैं एक सिंगल बना रहा हूं. राइट. अब देखो उसमें कर क्या रहे हैं हम लोग. व्हाट वी आर डूइंग हियर, दिस इज द डीपी एरे, दिस इज द डीपी एरे. व्हाट आई एम डूइंग हियर इज दैट, सी for the, see, I'm saying if I will go till this particular point, then what is the maximum energy that I will get? That is what I will store in this DP array, right? So if you will this give indexing to this DP array, it is like this. It is a take and not take DP I'm applying. Okay. So see, for the 0th house, means for the 0th energy drink, in the 0th hour, तो 0th hour में हम क्या बोल रहे हैं कि अगर हम फर्स्ट ड्रिंक पे होते हैं अभी, या अगर ये लेट्स से दिस इज 0th ड्रिंक, दिस इज फर्स्ट ड्रिंक, सो आई एम सेइंग that in the 0th hour, if I am in the 0th drink, then what is the energy I will get? So it will be obviously 5. In the 0th hour, in the 0th drink, energy will be 5. And in the 0th hour, in the first drink, energy will be 2. This is the base case of your DP. If you will see here what I did in the solution, a basic 4-line DP I have written. So what I did here, I'm simply saying I'm creating a DP array. I'm creating a DP array, okay, of size n plus 1, because I'm taking one base indexing in this DP, okay, and initially everything is 0, initially सब कुछ 0, ठीक है. तो बेसिकली हमने क्या मान लिया, हमने यहाँ पे एक और मान लिया इसके पहले. If I will give you, so I have taken a one base indexing here. So I will remove this all. I receive, like it can also be done in 0 base indexing, but I want to explain the same way how I've written the code. That is also a very modular and a simple code also. So I don't want to change the logic and my code also, right? So I'm just changing the little implementation so that it matches how I have implemented the code. So basically in code what I did, I have taken a DP array of size n plus 1. So it is going like this. So basically DP array mein the 0 index is considered as 1. Basically it's a one base indexing we are having here. Okay, बहुत the difference नहीं है, ठीक है. And initially all are 0. So I will assume कि okay ये दोनों चीज़ 0 है. मतलब obviously if you have not taken any drink, then it will be just 0. Okay. इसको भी आप one base मान लो, because we are considering that one base. तो उसको बाद में वहाँ पे -1 कर देंगे in the indexes to satisfy the 0 base indexing. You will understand, okay, don't worry, you will understand. अब ऐसा हो गया, ठीक है. अब देखो आप, I am saying that you are, so I am starting from the first star and I will go up to the last star. Okay. Up see, when you are at this particular R, you have 4 options. Let's first consider the first drink option. एक ऑप्शन क्या है कि आप इस ड्रिंक को ले लो. So if you will take this drink, this 0th drink at the first hour, तो आपको कितनी एनर्जी मिलेगी? हाउ मच एनर्जी यू विल गेट? यू विल गेट एनर्जी 5. इफ यू विल टेक दिस ड्रिंक एट द फर्स्ट आवर, you will get the energy 5, right, and you have also calculate what is the energy just before it. What's the energy just before this drink? तो भाई यहाँ इसकी 5 है, in this first hour 5, but what was the energy up to 0th hour? वो add हो जाएगा ना. So basically till here energy will be 5. That is the first case. So if you will see what I am doing, this is the case take energy A. So when I'm taking the energy A, what I'm doing is I'm simply saying my value of dp of I0, मतलब ये जो value है, dp of I0 is equal to maximum of current value dp of I0. By the way, this will not be current value dp of I0, comma dp of I minus 1 0. कि I minus 1 तक कितना energy थी? What was the energy till I minus 1 plus the current value of energy drain, which is 5. Okay, and same case is for the energy B. So I'm saying take energy or energy drink B. So when I take energy drink B, so I'm doing the same for the first index. So first index is considered as B and 0 as A. Okay, here it will be 2 because current is 2 and before it was just 0. Okay, before it was just 0. Right, amazing. Up next बहुत important case. Next case is that this is the take case. Take case means you are taking energy A, you are taking energy B. अब let's take the not take case. अब not take case कब करोगे? Not take case happens when, let's say you are not taking this energy. When do we don't take this energy? When we don't take the energy of a current R if we are coming from a different type of energy. Let's say अगर हम इसके पहले B से A में आ रहे होते ना, तो हम इस 5 को ना लेते हैं. स्किप करते फिर आगे बढ़ते। तो when I'm coming from a different R, then I will not take, but इसके पहले कोई एनर्जी थी नहीं। बाय द वे यहाँ पे मैंने जीरो कंसिडर कर लिया है, बट डोंट वरी, I will in the next step I will tell you how to do. अब let's say this will come. अब when this will come, what will happen? If you will see, this is 1 and its previous dp was 5, so it will be 6. Simple. dp of I0 is, अभी मैं आपको बताऊंगा, don't worry, this I will tell you in this step. This is nothing but previous value of I minus 1 plus the current value of energy. Right. इसके लिए क्या होगा? Its previous value, which is 2 here, my till here it was 2 plus 1 3. Okay. Now understand very carefully. Next thing is that maybe it is the case that here you are not coming from here. Maybe you are coming from here. And when you are coming from the second, from the below, from the different energy drink, then you should not take this. You should only take this value. Means you are not taking this case. So I am saying I am not taking, it is the not take case of energy A, that you are not taking the energy A. And when you are not taking the energy A, that means you are coming from the different energy of here. So this is actually, this is for A. Okay. So when I'm not taking this current energy A, that means you will see my dp of I0 value is dp of I minus 1, not 0. dp of I minus 1, because I am coming from here. So this energy will be added, which is 2, and this 1 will not be added, it will be skipped. But because we are taking maximum, here already 6 hai, so 2 we will not take. Okay. Now let's check for this. So here, if I will not take this one, then I will obviously take this. So if you will see, it is saying max of dp of I minus 1 0. So if you are taking the 1, but you're not considering it, here I am saying not take energy B. So if you're not taking energy B, that means you're switching from the energy A. So यहाँ पे क्या होगा कि आप इसको नहीं ले रहे हो, but you are taking this from here. What is this? This is 5, right? अब here maximum will be 5. तो here ये आपका 5 हो जाएगा. 5 कैसे? आप ऐसे कर रहे हो, आप यहाँ से आए और फिर आप यहाँ स्विच कर गए. इसको नहीं लिया, but you switch here, right? This is how we are getting 5. Similarly, now move forward. Here, first case is that 8 plus its previous one 6. So first case is 8 plus 6. Second case is don't take this 8 and just take 5. And maximum of both will answer. Here kya hoga? First case is 9 plus 5, 14. And second case is don't take this 9, take this one, which is 6. Right? And so on. Is तरीके से will found till the very last. And then for the very last two values, whichever is the maximum will be your answer. Let's find for this. So by the way, यहाँ पे 14 कर लो, because it is 8 plus 6 14, and ये वाला था 5. It will be 9 plus 5 14. Okay, here also it's 14. 9 plus previous is 5, and comma either don't take the last 6. So max is 14. Okay. Now come here. 2 plus 14 16. Either take 14. Here one. Or either 6 plus previous 20, और just take this 14. मतलब previous का other drink का लेना है, current नहीं ले रहा है. Take case, not take case. And maximum of 2 I will consider for the next. तो आप देखो मैं आगे से maximum को consider कर रहा हूँ. मैं लिख दोनों रहा हूँ. I'm writing both just to explain, but I'm considering just the maximum one, right? Now here it will be 6 plus 16 22, and either this one 20. ये गया. It's not maximum. Either take 22 from here also, 20 plus 2 22, or either take this one 16, which is gone. Okay. Then here it is saying ki either take this 23, 22 plus 51 23, or just take 22. Either here 22 plus 27, or just take 22, gone. And here 4, so it will be 27, 24 plus 4 27. Either previous one 27, both are equal. Either 24 is just 8 35, or 23. So finally you can see the maximum of these last two values 35, and that is the answer, the maximum of both. And you can see we also discussed, and we were getting 35 as the maximum. Is tarike se na? This is how we were going, and we were getting 35 as the sum. Okay? So this is how we are doing, guys, and we are using this DP technique to solve. Okay? You can see lastly we are finding the maximum of dp n0 and dp n1. तो because it's one base indexing, यहाँ पे हमने I minus 1 लिया हुआ है because it's one base indexing. Okay, and for DP it is as usual one base indexing. Amazing. So this is how guys we are solving this particular problem. If you see the time and space complexity is just order of n into 2. So we can say order of n only, right? And space complexity is also order of n because we are taking a this DP array. Okay, amazing, amazing. So guys, this is what the first two problems were. I hope that they've got the understanding of this with these first two problems. Now let's move to the next problem. So now let's discuss about this third problem, which is find the largest palindrome divisible by k. This problem actually, I'm not sure how other people have done. I didn't got the time to check, but I have done in a very, basic manner, a very basic manner of finding, all the cases. So what I have done actually here is that you are given two positive integers n and k, and what you do is you have to find the integer x. That integer x should have n digits, and it should be divisible by k, and it should have be a palindrome. So you have three things. See, so what you are given with, two values n and k. Okay. Now what you do is you have to find the largest integer such that it is divisible by k. क्यों k से divisible हो. Secondly, it should have n digits. Okay. And thirdly, it should be a palindrome. It should be a palindrome. Right. This is what the case is. Okay. Amazing. Up, understand very carefully. Here, we cannot do it just as a simple maths problem. Why? Because n is up to 10 to the power 5. Means a number who has 10 to the power 5 digit, that number will go up to the range of 10 to the power 5. Means it will be a very large number. So we cannot solve it just by the classical approach of maths. No, it is not solvable. So means we have to apply some observation, we have to apply some logic to solve this problem, and that is what I did. Okay. Let me tell you how we can solve this particular problem. Okay. अब आप देखोगे यहाँ पर n is very large, that is understandable, but k is very low. K is just between 0 to n, 1 to n. So what I have done, for every number from 1 to n, I have separately checked ki how it is possible to make a longest number of n digit, which is the largest one also. Okay, not the longest, sorry, largest, right? Largest one also, which is the largest one also divisible by k. So I am looking for how to apply that logic. Let's see how I can apply that logic. Let's see that. Okay. देखो, सबसे पहले आता है k is equal to 1. Understand very carefully. So when k is equal to 1 is there, that means okay, k is equal to 1 छोड़ो. Okay, let's say k is equal to 1. So if k is equal to 1, I can take any number because every number is then divisible by k. So if n is 1, I will just simply take 9. If n is 2, I will simply take 9, 9. If n is 3, I will take 9, 9 and so on. That's it. ठीक है? K1 के लिए कोई दिक्कत नहीं है. And not just for K1. For K3 and K9 also, answer will be this only. Because this value 9 is also divisible by 1, 3 and 9. So whenever the value of k is 1, 3 or 9, we can just place 9, 9, 9, 9, 9 up to whatever digits we have. This is the first observation we have. So when k is 3, so all the 9 and 9 are divisible by 3 and also by 9. So the basics say that when k will be either 1, either 3 or either 9, our output will be just 9 n times. And that will be my answer. If n is 4, 9, 9, 9, 9. ठीक है? I hope you got understand very clear. So 1, 3 or 9 हो गया. Okay. Now let's check for 2. So by the way, for considering the corner cases, what I did, I have separately handled for n is equal to 1, n is equal to n is equal to 3. Means when we have just one digit, 2 digit or 3 digit number, I am handling it separately. I will tell you why later on. Okay. So if you will see here, for n is equal to 1, for every k, I have written the answer. It is very genuine. For k is equal to 1, 9, as I discussed, 9 is the maximum number of one digit which is divisible by k. For 2, it will be 8. 9 is not possible, 8 is there. For 3 it is 9 only. For 4 it is 8. For 5 it is 5. For 6 it is 6. For 7 it is 7. For 8 it is 8. And for 9 it is 9. Right. This is how we will have for n1, only for one digit number, for given k, what is the maximum number of length 1 which is divisible by k. I have just hard coded this value. I hope this is clear. And same for 2 and 3 also. When n is equal to 2, then what will be for 1? It will be 9 9. For 2 it will be 8 8. You can see more than 8 8 there is no number possible. For 3 it is again 9 9. 9 also it is 9 9. And I've mostly done here, just repeat these two digits, what we have took here, what we took here, we just repeated it, and that's it. That is for 2. Because 9 cannot be there, it can also be 98 in 2 case, because the value should also be palindrome, so it is 8 8, right? Up for n is equal to 3, what I will do? For n is equal to 3, what I will do is, that I will, again, I have hard coded the value, here the value is a little different. So if you will see here, for k is equal to 1, it is 999. For k is equal to 2, what I did, I changed c, because c, if my value is 3, right? So my initial answer is 999. But this 999 is not divisible by 2. So I have to make its last digit to a number which is divisible by 2. And if I will change this 9 to 8, I have to change this also, because it's a palindrome. I have to change both of them, right? So that is what I did. Okay, then this is also there. Then for k is equal to 8, if you will see, 8 8 is the maximum possible palindrome which is divisible by 4. Then for 5, it is this 5 9 5, because it is 999, but you need either 0 either 5 at the last. So if it will be 0, it will be 0 here also, not possible. So it will be 5 and 5, right? Then for 6, it is again 8 8 8. You can check why 8 8 8, because for number to be divisible by 6, it should be divisible by both 2 and 3. So 8 8 8 is a number, you can see it is divisible by both 2 and 3. Okay, so it's at 6. Then for 7, it is this 8, it is 8 8 8, and for 9 also it is 9 9 9. Okay, so these are some hard coded values that we have taken. Okay, for this particular case, these are some hard coded values that I have taken. Okay, up now comes the main logic. Okay, Abhinav, 1 to real कर लिया, क्या पूरा 10 to the power 5 तक करोगे? It is not possible, right? Now we have to apply some logic, which I have written here. This for 1, 2 and 3 I have taken it separately. The only reason was because I just a minute. This I have taken separately because it will actually have some corner cases in my later implementation, because my later implementation wants digits of at least size 4 in some of the cases. So I have taken 1, 2 and 3 separately, right? अब समझते हैं बाकी के लिए. अब first of all, ये तुम्हें पता है कि when I am considering a number of size 9 digit number, so initially I will take 9 digits in it. Okay, and because we will have two different cases, let's handle one case for even, or okay, we'll take it later. So let's say अगर हमारा n अगर 5 है, so it will be 9 9 9 9 9. तो हमने initially हमारे आंसर में, initially in my answer I put this 9 9 9 9 9. Okay, initially I put this in my answer. Okay, now what I will do is that when my k is 1 or 3 or 9, so as I discussed, when k is 1 or 3 or 9, my answer will be this only, 9 9 up to n. So हमारा answer as it is, I will written my answer. If my k is either 1, either 3, either 9, this is the first logic. कि अगर k इनमें से कुछ भी है, simply written the answer. Okay, this should be clear. Amazing. Let's move forward. Now when my k is 2, that means this number should be an even number. Then only it is divisible by 2. For making it even and the largest possible palindrome even, what I can do, ये 9 तो नहीं हो सकता. It should be an even number, which is the largest even number, 8. And if you're making the last digit 8, I have to also make the first digit 8. And that's it. This is what I will do in case of 2. In case of 2, the last digit of the answer and the first digit of the answer, I'm making 8 and 8. Both I'm making 8. Right? So this is how for k is equal to 2, it will be just 8, then whatever 9s you have, and then again 8. बीच में 9 रहेंगे, right? Amazing, amazing. Now comes for k is equal to 4. For k is equal to 4, guys, what is our logic? For k is equal to 4, our logic is that if you see the divisibility rule of 4, the divisibility rule of 4 is that last two digit should be divisible by 4. So let's say if I'm having n is equal to 5, it will be 99999. Okay, it will be this 99999. But in this case, what I will do? This is not divisible by 4. I want my last two digit divisible by 4. And whatever my last two digit will be, same I will make my last first two digit also, because it should be palindrome. And if you will see the maximum, आप देखो कि क्या क्या दो डिजिट नंबर होते हैं जो कि 4 से डिविजिबल होते हैं. So you can see maximum two digit number divisible by 4 is 96. But if you will place 96 here, you have to do 69 here, and it will become a small number. It is a number 69,000 and something, which is small because greater is possible. But instead of 96, if you will actually take, you cannot also take 92. If you make it 92, it will be 29. No. But if you will take 88, guys, this is the maximum possible present. If you will make the last two digit of this as 88, then it will also become 88, and this is the number that will be the answer. So basically, whenever k is 4, you have to make the last two digit 0, n minus 1 and n minus 2, and first two digit 0 and 1 as 8. आपको अपनी last two and first two digit 8 करनी पड़ेंगी, and that will be the answer. Okay, I've written it. That's it. Okay. Now let's check for k is equal to 5. For k is equal to 5, what I am doing is that, again, I have initially my answer as 99999. For k is equal to 5, for divisibility of 5, there is only one rule, and the rule is that last digit should be either 0 either 5. We should not make it 0. If you will make it 0, first should also be 0. It should not be there. It will be a lesser number. So you want the largest number, I will make it 5, and this also 5. Nothing different. Just simply make the first digit and last digit as 5 in this case. Now guys, for 6 and for 7, it is little complex. Let's understand what we are doing. It is little complex. ठीक है. 8 के लिए देख लेंगे पहले. 8 के लिए क्या करना है? 8 के लिए is nothing. 8 के लिए again, if you will see, the divisibility of 8 is very similar to 4. 4 में क्या होता है कि last two digits should be divisible by 4, right? 8 में क्या होता है कि last three digits should be divisible by 8. This is the case. So if you are taking like 9999 whatever, तो last digit में ऐसे रखने जो maximum हो divisible by 8 हो. So if you will see, just like in 4 it was 88, in 8 it is 888, and when we're making last three digits 888, you have to make first three digit also 888. This is the only possible way for 8. So you can see I'm making the first three digits and last three digits as 888. Okay, amazing. Now let's check for the other case, which is the 6. 6 is actually little complex. I have done. I'm not sure if others have also done, but yeah, I have done it. Okay. Now let's say initially the number is like this. In this case, actually, the case of odd and even both will come. So let's take an odd number. When it is a, let's say 7, तो क्या होगा कि इस तरीके से 999999 will be there. Okay, 7 times 9 is there initially. ये हमारा initial answer है. Okay. अब divisibility of 6 is that the number should be divisible by 2 and 3 both. This is the divisibility probability of 6. Okay, if you want a number to be divisible by 6, that means that number should be divisible by both 2 and 3. वो number 2 और 3 दोनों से divisible होना चाहिए. Okay. If the number is divisible by both 2 and 3, that means it is also divisible by 6. This is the case. Okay. अब कैसे इसको handle करेंगे? How we will handle this case? So for handling this case, what I am doing is, first of all, currently this number is not divisible by 2 because first and last digits are 9. So first thing that I will do is, I will make it 8. So you can see, first to make it divisible by 2, I made the first number and the last number 8. First and the last number 8. This is what I did. Okay? But making this 8 doesn't mean it is not divisible by 3 also, because what is the probability of divisible by 3? If we want a number divisible by 3, that means sum of all the numbers will also be divisible by 3. सारे नंबर का सम भी 3 से डिविजिबल होना चाहिए. So now I will first of all find the sum of all the numbers in this answer. कैसे निकालेंगे? So if you know, initially all the answers were 9, so the sum will be 9 into n. और उसमें से हमने दो 9 को 8 कर लिया. We made 2 9 into 8. So 2 sum is decreased. So now the final sum is actually this 9 into n minus 2. तो ये हमारा sum है. ठीक है. अब देखो, if the sum is divisible by 3 already, if it is already divisible by 3, then there is no problem. For example, if we will see here it is not, I think, because it is 9 into 7, it is 61. Okay, here you can see the sum is 61. So it is not divisible by 3. So if it is not divisible by 3, what we can do? We have to actually decrease more so that it is divisible by 3. Okay, तो अगर already divisible by 3 है तो फिर कोई दिक्कत नहीं है. Then simply return it. If it is not divisible by 3, then what I will do? Then I will have some cases. So I have two cases. First is if its remainder is 2 or if its remainder is 1. For both I have two different cases. I'm not sure whether it is required. Let me think. I think it is not required to do this, but yeah, I have taken it in two separate cases. It will be easy. अब मान लो जो sum है वो उसका modulus 2 आ रहा है. Let's say the sum is having modulus 2 by dividing with 3, means it is not divisible. ठीक है. Here modulus 1 is coming. Let's take a different example. Let's take the example n is equal to 8. So when n is equal, let's say for n is equal to 6. Yeah, n is equal to, no, 6 nahi, 8. When n is 8, you can see these are the 9. First two digits I will make 8. These are 6 digits left. And your sum here will be 9 into 8 minus 2, means 70. Now when sum is 70, you can see here that, okay, यहाँ पर भी 1 ही आ रहा है remainder. I want remainder 2. क्या remainder 2 कभी नहीं आएगा क्या? Okay guys, this case will never happen. Remainder 2 will never come. Okay. There will always be remainder 1. ये केस तो कभी होगा ही नहीं. Why I did this at that time? That time I didn't got this. Okay, wait guys. देखो, initially this number was divisible by 9. उसमें मैंने 2 कम कर लिया. And when 2 is less than a number which is divisible by 3, that means एक रिमाइंडर बचता है लास्ट में. तो अब देखो यहाँ पे एक रिमाइंडर बच रहा है. अब मतलब आपको कोई एक वैल्यू कम करनी है. You have to do any one value less. So see guys, in this case, doing this one value less is very easy because here n is odd. So because n is odd, it contains odd number of elements. So I will take the middle element, this one, which is index number n by 2, and I will just made it 1 decrease to 8. तो अब हम क्या कर रहे हैं कि when n is odd, then we are just making my n by 2th index 1 decrease. मतलब I'm making it just 8. 9 to 8. ये तो easy है. अब you can see now it is divisible by 6. But the problem comes here. यहाँ पे क्या problem आ रही है? Here the problem is that कि I don't have any middle number. Okay. So यहाँ पे middle 2 हैं. So if I will make this one to 8, it will be wrong because it's not palindrome. If I'll make this to 8, again it's not palindrome. So what to do? क्या करेंगे हम लोग? What to do in this particular case? So then what we can do here in this case is that if both are not there, then it will be that I have to make both of them decreased. Again, if you're making both of them decreased, then you're making 4 sum less. तो आप 2 बार इनको decrease करो, because when you will do 2 times decrease of them, then finally you can see total sum is decreased by 6, means again it's a multiple of 3. And you cannot decrease it anywhere else. You cannot decrease it here, because if you decrease it here, number will become very low. You should always do it in the middle. So you will make it minus 2 in both of the middle. This is n by 2, this is n by 2 plus 1. in both of these two middle nodes. Okay, and by 2 and minus 2 minus 1, by the way. I'm subtracting by 2. And then I'm writing the answer. Okay. This is what I'm doing in the case of 6. Okay. Amazing. Amazing. Now guys, finally the case of 7. A very interesting case. By the way guys, first of all, let me tell you how we can check that whether a number is divisible by 7. How we can check that whether a number is divisible by 7. For 7, it's having a very weird, rule. If you will see, I saw a Geeks4Geeks article. Divisibility rule of 7. Okay. Okay. I will check you the check number is divisible by 7 GFG. So I saw an article actually. ये वाला article है. To check whether a very large number is divisible by 7. So when you check that a very large number, just like we are having in a form of a string, क्या वो अगर 0 से 7 से divisible है? For checking that, this is the formula. You can read this article. तो basically अगर ये number है, तो first of all you will break that number into different parts of 3, 3, 3, and then you will subtract it with each other in alternative manner. And if this final value is divisible by 7, that means this whole number is also divisible by 7. This is the rule. Okay. And here is the code of that. यहाँ पे code मिल जाएगा आपको. And what I did, I just copy pasted this code here. You can see here at the top, I have copy pasted a code of checking that whether a number is divisible by 7. But you will say, Abhinav, why you are using it? Do we are we checking for all the numbers? It is not possible. No, don't worry. We are not checking for all the numbers because I also found a pattern, which is the main. The pattern is that whenever you will check the divisibility of 7, it's a very interesting case. Okay, it's a very interesting case. If you will see, let's say if I'm seeing the first one digit number which is divisible by 7, it will be just 7. 2 digit number is 7, 7. 3 digit number, if you will see what it was in our case, it was 959. Means border mein there is 9, in between there is 5. Right? In between there is a 5. If you will see for 4, let's find. So for 4, initially I will check for 9999, it is not divisible. Then let's check for 9889, 9779. So you can see 9779 is a number which is divisible by 9. Let's check for 5. So initially I will check for 9999. So 99999 ये नहीं है. Now middle का change करो. 8, no, 7, yes. So if you will see 99799 is divisible again. You will say okay Abhinav, it's just 7, 7, yeah. No, कहीं भी 5 भी आएगा. देखो. Now check for 6. It is divisible, no. Okay, it is also divisible. Okay, so 6 clear to even. This is itself divisible. Okay, now for 7, let's see. 9999999 divisible by 7. It is not divisible. Let's change the middle number to 8, to 7, to 6, to 5, 4. Yeah. So here it is divisible by 4. Now let's check for 8. Let's check change the middle two numbers. So it is not there. Check for 8, 8, 7, 7, 6, 6, 5, 5, 4, 4. Yeah. So if you will see, it is 9994499. So basically, आप देखो कि there is a pattern that is going on. For first 3 we have handled separately, but for later on you can see in all the borders we have 999. Just the middle number is replaced by some other number between 0 to 9. कोई भी हो सकता है. यहाँ पर it is 5. Here it is 7. So if it is an even number, तो middle 2 numbers are changed. If it's an odd number, then only the middle number is changed. यहाँ पर नहीं change हो, 9 रहा. यहाँ पे 4 हो गया, यहाँ पे 4 हो गया. And maybe later on some other number will be changed. So only the middle numbers are being changed. To what, that we don't know. तुम सबके लिए check करें. So what I'm doing is that for 7, I'm making a loop from 9 to 0. 9 से लेके 0 में सबके loop check कर रहे हैं. And I'm changing my middle number. If it's odd, then only the middle number n by 2. If it's even, then 2 middle numbers are there. Both I'm changing to this new number 9. and for that new number present, I will check whether it is divisible or not. For example, let's say हमें check करना है 6 के लिए, तो I will initially take 99999. I will check. Is it? No. I will make it to 8. Is it? No. Then 7. Then 6. Then 5 and so on. And it is a guarantee that any one of that will always be divisible by 7 and you will just return it. This is the case. This is the case. Okay. So here our observation was required. If you will see, mostly for 7 and 6 we did some calculation. Others it was just straightforward. Okay. So guys, this is how I am solving this particular problem. I hope that you have got the understanding of this particular thing. But if you still have any doubt, you can ask that to me in the comment section below, or you can also join the Telegram channel or the WhatsApp channel to ask your doubt. Okay. Now let's move to the next problem. So guys, finally the last problem for this video, which is just the second version of our first problem, count substrings that satisfy K constants. The only thing is this we cannot solve using order of n cube, because here we also have queries, right? And we have a very hard constant. So here they are not just asking it for the whole array, that how many possible K constant subs array are possible, but they are giving us query and they're asking us that between that L to R, how many substrings are there that satisfy K constant, right? So this is what it is. Whenever query comes, we know, okay, that in most of the cases segment tree is a possibility, but this is a actually exception where it can also be solved in other way apart from segment tree. Yes, there is a possible approach using, guys, binary search that we are using here. Yes, using binary search and prefix sum we can solve this problem, and that particular approach we will discuss in this particular question, right? Now let's discuss first of all. Let's have a test case. Okay, so let's take this second example only. It is a good test case, and through this only I will explain you. Right. Okay. By the way, in this second example, K is only 1. Let me take some other string then. Okay. So let's say string is like this, where we have. By the way, this is also fine. K is 1 is also fine. Not a problem. Let's take this only. Okay. So ये हमें दिया गया है, right? So we have some queries with us. We have some queries with us, right? These are the queries, like 0 1 0 1 0 1. Okay, but yeah. Now see, guys, what we are doing first of all. First of all, we have to identify the range that from this L to this R, from this L to this R, our sub-array is a K constant. Understand one thing very carefully. If from one index to another index, if a sub-array is, K constant, that means the middle sub-arrays are also definitely K constant. For example, you will see that in this particular case, this are K constant. This is an array which is K constant. Actually, I want to take a different case here. Let's do one thing. Let's make this K to 2, and let's have a greater value of this. Okay. So this is the string that I've taken. Let's copy it. Okay. Now if you can see K is 2, right? So if K is 2, you can see that, okay, this particular is a sub-array which is K constant. Why it is K constant? Because maybe zeros are present more than K times, but 1 is present less than K times. So it is a K constant array, right? Amazing. But if this is a K constant sub-array, means every sub-array inside it also, this one, this one, this one, this one, every array inside this sub-array, means every sub-array of this sub-array will also be K constant. That is the first logic. Okay, amazing. Now let's see what we are doing. So I am first of all having two things with me for pre-computing my prefix array. What are we actually pre-computing? So I'm having two things. So if you will see here, okay, this became very large. Let's make it like this. Yeah, this is fine, I think. So this is a string of length 9. Okay. So what I will do, I will create two arrays here. Two arrays. One will be a vector v, and second will be a vector. Second will be a vector prefix. and I will tell you the use of both the vectors, don't worry. Zero, 1, 2, 3, 4, 5, 6, 7, 8. We just need 8, right? Let's remove this. Okay. Badhiya. Okay. Now this is the vector v, and so here k is 2. Okay. Yeah. And similarly, I will have one more vector of the same size, which is vector prefix. Okay. Vector prefix. Now understand very carefully. As the name says, देखो v में क्या कर रहे हैं हम लोग? For v, whenever I will see a subarray starting from L to R, which is actually having a k constant array, I will store it in this v. For R, for this L, it is having possibility. Let me give you example. I will start from L0 R0 and I will move on. ठीक है? तो पहले मैंने इतना लिया. अब बताइए क्या ये एक like is this k constant array this much? Assume कि ये आपका LA R है. I'm not writing here. Okay. Is this a k constant array? Yes, it is a k constant array. Our current L is 0 and R is also 0. So what I will do, I will make my V 0, and you can see जब हमारे number of 1 k से ज़्यादा हो जाएंगे, if my number of 1 is greater than 0 and number of 0 also greater than k, means in this case it is not a constant, it is not a k constant array, then only will increase my L. Initially my both will be there. So you can see this case is not there, my both 1 or 0 is less than equal to k, तो ये case नहीं होगा handle, right? So I will simply make my VR equal to L, and my V prefix R will be equal to R minus L plus 1, which is the length of R sub array of that particular मतलब बेसिकली इसका मतलब क्या है कि इस R इंडेक्स पे एक सब एरे खत्म हो रही है जिसकी लेंथ इतनी है. At this R index, a k constant sub array is ending, which is having this much length. Okay, so what I will do, so understand the logic. Okay, logic यही है. I will tell you the logic. Okay, I'm just giving you a dry run also, but later on you will understand the logic also. That basically through this logic we will be able to find it between two different queries what is the number of arrays, right? So if you will see here, if this is L0 and R0, so I will make V of R equal to L, meaning V of 0 equal to 0, and this will become 1 because the value of R minus L plus 1 is 1. Okay, then I will move forward to here. Here again it is possible, R became 1, so here again for VR L is 0 again and it will become 2. This is also possible, this is also possible, so here this will again 0, 3, again possible, 0, 4, again it is not because कब fulfill नहीं करेगा जब 1 greater than k and 0 greater than k हो जाए. अभी it is within because 0 are 3, 1 is 2, so again V of R will be L, which is 0 and 5 is the length now. Here again 0, 6. You will see here now the that changes. Now the particular thing is changed. What? We are actually not having, because here number of ones are 3 and number of zeros also 3 are 4, means both are more than k. Now I will increase my L until they again became less than equal to k, any of that, right? So I will first remove this, then I will remove this. Now you can see again ones are 3, ones are 2 and 0 is also 3. So L आपका हो गया 2. Now for 6 L will become 2 and length will become 5. Now for 7 again 1 आपके 3 हो गए, not possible, तो again यहाँ से L हटेगा यहाँ तक. Okay, not till here, only till here, because of now 0 or 2 only, less than k, right? So आपकी इतनी लेंथ हो जाएगी basically, more specifically 7 तक, right? 2 zeros 3 1, it is possible. Both should not be greater than k, right? So now for R, this is L is 3, R is 7, so it will be 3, length is 5. This again I cannot take, both became greater than k, so this will be gone, so it will be 4 and 5. तो इस तरीके से what I am telling is that starting from index number R कि भाई ये अगर R2 है तो उस 2 के पीछे कहाँ तक एक k constant array possible है. That is what I am finding using this v. Means from 6 till 2, means from 2 to 6 there is a k constant array. Then from 3 to 7 there is a k constant array. From 4 to 8 there is a k constant array. From 0 to 4, this is what we are finding from here. और अगर यहां से यहां तक है तो बीच में तो होगी, right? And this prefix is actually counting what is the size of the array. Why I'm calculating the size? Because when I'm saying that, okay, from 0 to 3 there is a sub array of k constant ending at r. So not just 0 to 3, 2 to 3, 1 to 3 and 0 to 3 all are there, right? And 3 to 3 also. तो कितनी possibility हुई? 4 sub array बनी ना, which are ending at 4. Means there are 4 sub arrays which are ending at 4 or ending at 3. So there are 4 sub arrays that are ending at 3. Ending at 3, 4 sub arrays follow कर रही हैं, right? 4 पे कितनी? 5 है. 1, 2, 3, 4, 5. So this prefix is storing that how many sub arrays are there which are ending at that r at this 4th index and are k constant, जो वहां पे end हो रही हैं. And v is storing that a sub array which is ending at 4 from where it is starting, which is k constant. Are you getting or not? Amazing. Now using these both the things, and also here I will find the prefix sum of this prefix, because I will not just find number of sub array which are ending at 4. I will find all the number of sub array which are ending at 4 or before that also. तो एक prefix sum इसका same का ले लेंगे. तो nothing, it will be 3 plus 3 6, 10, 15, 21, 26, 31 and 36. Okay. Now let's see how we can use it. Now when I'm having a query L and R, कि हमें I0 से लेके I1 तक चाहिए, I will first of all make a call and I will find a value, because we know here all the L are present. Now I will find the value that for a particular L, ठीक है, for a particular L, कौन सा L है जो इस I के या तो greater है या फिर बड़ा है. मान लो हम लोग बोल रहे हैं I have to find starting from 3 to let's say starting from 1 till 7, let's say for example कि हमें 1 से लेके 7 तक का चाहिए, ठीक है. तो कौन सा ऐसा R है, कौन सा ऐसा R है, which R is there which is starting from 1, or if not 1 more than 1. So I will search I will apply kind of upper bound here. This is the upper bound technique. Okay, for this I am finding the upper bound of this I0 which is L. कि कौन सा ऐसा L और R है जो कि उसके बाद से शुरू हो. तो आप देखो कि this will be the case. This is here. Okay, and not just I want the maximum R, right? Not just that R. तो हम minimum R like लेंगे, whichever is greater. Wait, so we will find the mid whose value is greater than I0, right? And then I will check for the smaller mid also. So basically this will be the case that I will get. From 2 to 6, this is a k constant array. This is the k constant array which is actually having, you know, k constants. है ये कैसे निकाला? Using this. Okay. Now how many sub arrays are between this? For finding this, what I will do, I will use this prefix sum. तो prefix sum हम क्या करेंगे? This will tell us how many sub arrays are there which are ending at 6 till 6. How many are ending? So they are 26. But तो पूरी आ गई. From there I will subtract this much part. This I will subtract. How? So temp में क्या store करें? Temp में we are storing that value mid. So this value है ना, this 2. This I am storing in temp. And this is our R basically. So ये हमारा R है और ये हमारा temp है. So what I did, I take the prefix sum of R, which is I0 by the way. So we are not just taking for this 6 by the way. We are taking for this R, which is given to us in the query. हम पूरा 7 से ले रहे हैं by the way. Not just that. यहाँ पे मैं 2 मिला कि 2 से 6 तक है. I will take up to 7 on. Whole up to 7. From 2 to 7 I will take. Right. I will take from 2 to 7. And from 2 to 7, this is my R. So I know that till R, how many sub arrays are possible which are actually which are ending at R. How many sub arrays are possible which are ending at R? वो बदल गया. But we don't need sub array before that. So how many sub arrays are possible before? वो minus कर रहा है. So I am taking prefix sum, simple prefix sum logic. Prefix of that R which is I1 यहाँ आर चेंज हुआ इसलिए मैंने आई विल नहीं लिया है, ठीक है। माइनस टेम्प्ट माइनस वन, मतलब बेसिकली what I'm doing is that from these both, this is my tempt, I'm subtracting this, just like we did in prefix sum, right? But this is not the answer. One more thing I will do. So because here my tempt is here, my r is here, it is telling me from 2 to 7, but remaining 1 का क्या, हमें तो 1 से 7 तक चाहिए ना, तो basically between 1 to tempt रह गया, 1 से लेकर tempt तक वाला part रह गया, it is remaining. So what I will do, whatever part is remaining I will count. You can see remaining part is tempt minus my L, my I0 यहाँ पे था, तो whichever part is remaining I will take that, और वो part भी it will be definitely a K constant. That part is a small part, that will definitely K constant. So with that part, how many sub arrays are possible? So if you know, if we have a array of size n, so basically n into n plus 1 by 2 sub arrays are possible. So if some part is remaining, for that particular part, whatever size it is, this much number of sub arrays are possible that I will store again in my answer. And finally, I will insert that in my answer. So guys, this is how I am solving this particular value. I hope that you have got the understanding of this particular approach. This was actually a really complex one. We applied prefix sum, we applied binary system, and multiple things about that. But yeah, this is how we do solve it. There's a segmentary solution also. If you want, you can check that also. But yeah, if you have any doubt, you can ask that to me in the comment section below. You can also join the Telegram channel to ask your doubt. Thank you.